Applications of Bernoulli's theorem. You see, Bernoulli's theorem has got very wide applications in our daily practical life. Step by step, you observe application of Bernoulli's theorem. First of all, we are using here Venturi meter, but before that, I'll tell you that like Venturi meter, we have another system also that's called Pitor's tube. Pitor's tube is used for measuring the wind velocity. And here, what we are going to do, we'll measure the velocity of the liquid in flow. By doing that, we can also find the rate of flow of volume of liquid in motion. This has three parts. You see, the entering part is bit wider. This is known as wide inlet. The middle part, you see, it's a throat-like appearance, narrower part. And then again, the divergent outlet is here visible, you can see. By using Bernoulli's theorem at the 2 points, you see the wider and this narrower, you could use this form of Bernoulli's theorem, dgh1. Similarly here, and few steps along with this law of continuity, if you simplify the two, you'll conclude that the rate of flow of volume, that is V upon T, this comes out to be A1, A2, root 2GH upon A1 square minus A2 square. This is the rate of flow of volume. So, use two equations only, Bernoulli's theorem at the 2 points, wider and narrower. Similarly, equation of continuity, and this is the combo application of both the theorem. The final result is this one. Now, if somebody asks what is the principle of aeroplane, see, aeroplane flies in the principle of Newton's third law. Propeller throws the air backward, that gives the reaction that takes it forward. But still, this phenomenon is not explained why the aeroplane doesn't fall down. The flying of aeroplane is based on Newton's third law, but it doesn't fall down. This is based on Bernoulli's theorem. So, credit goes to both the laws. If you are enjoying the facilities of aeroplane, you have to assign the credit to both Bernoulli and to Newton as well. You see, here the propeller has been shown. The upper part of the wing is wider, and that way the velocity will also be wider above the wing. When the velocity increases, in Bernoulli's theorem, Hawksby's law, second part I told you, when the velocity is large, pressure would be smaller. Here the pressure becomes smaller. Whenever across a membrane, the two sides having the pressure difference, then there will always be a force from higher pressure to lower pressure. Here we have concluded that above this wing the pressure has reduced. Obviously, the force would be developed from lower part to the upper part to balance this pressure difference. Now, this is our ambition. Actually, aeroplane could fall down because of the gravity, because of the weight that is downward. And to counter that weight, we have produced another force that is acting upward, and this has arisen because of the pressure difference. So, you could say now that aeroplanes fly because of Newton's third law, but aeroplanes doesn't fall down because of Bernoulli's theorem. Blowing of roofs by wind. Suppose this is tin shed, and there is a storm, fast blowing wind. You see, when the speed is greater above the tin, obviously the pressure would be reduced over here. But you haven't disturbed the pressure inside the house, that is below the roof. Below the roof is still the same pressure continues, whereas above the tin you have maintained the pressure low. Again, the same thing, a pressure difference has developed across the two faces of the tin. Below it is greater, above it is smaller. A force will be developed from higher pressure to lower pressure. This will make this tin set fly away. That's why in a storm, tins fly away, roofs fly away. Another very interesting example, suppose two buses are, roadways buses are passing side by side. You know, whenever inside the fluid, when some solid like boat in water or aeroplane in air or even the buses in air, when they move along with the solid, the gas or the liquid will also be in motion, that is beside that body. When the buses are moving in the same direction, in between them, the air beside them will also be having the motion in the same direction. And because both the velocities are in the same direction between the two buses, that velocity will increase and obviously the pressure will decrease. You see, it's very interesting. Between two buses moving in the same side, the pressure has reduced, whereas outward the pressure hasn't been reduced. So, outside the buses, the pressure is greater, and between the two buses moving in the same direction, the pressure has reduced. There is a force from outside towards inside. You could say, in short, that the two buses will feel the force of attraction when moving side by side in the same direction. This is also one very good example of Bernoulli's theorem.